sırada The Challenges of AI Ethics, yani yapay zeka etiğinin zorluklarından bahsedeceğiz. Daha önce de misafir ettiğimiz bir ismi ağırlayacağız. Northeastern Üniversitesi'nin Institute for Experiential AI baş araştırma görevlisi Sayın Ricardo Baeza-Yates var sırada. Ricardo bizlere yapay zekanın etiğinden, uygulamalarından ve karşılaştığı zorluklardan bahsedecek. Ricardo, hi. Thank you very much for joining. It's great seeing you at SmartCon again.
Thank you. Thank you for inviting me, and I will go right away to my presentation as we are late on time. So I will have to fly.
We're looking forward to it. The stage is yours.
Thank you. I will have to fly over the slides because typically I take 1 hour for this, and I cut it, but it's hard to cut it more. So the first part will be some ethical issues that have my own personal bias. So these are the 4 worst problems that I think we need to deal with. Discrimination is clearly the main one. And then we will discuss different things that are more like future in the future. And then I will say what we can do now. So the first problem is what I call the course of bias. Basically, any algorithm receives biased data because information is biased. Otherwise, it will be like random noise. And here we have the first bias. When we think about bias, we think about something negative, but bias can have both sides, positive and negative. But in the case of negative one, so we need to ask if the algorithm should be neutral or fair. But most designers never ask this question, and then they just use the data as is, and they have the same bias. And sometimes the bias is amplified. Now, what it means to be fair, that's very hard to because it's a societal decision. It's not a computer science decision. But if the bias is amplified, clearly bias is not only in data. And you can check my paper in Communication with ACM in 2018, where I show all the other types of bias that you can have also in the algorithm and also in the feedback loop between the user and the algorithm. I will not have time to talk too much about those today. But it's not only in the data. Now, what is being fair? So this is a famous cartoon that shows the difference between equality, equity, and justice for 3 people who want to see the football game. Of course, we want justice, but justice takes too long to be resolved. And what we do is equity. So equity is what is called in the US an affirmative action, and this is a positive bias. So we do something to change the current social trend. If you're interested in this topic, I strongly recommend this movie called Bias. You can find it in Netflix, and also you can see the panel we did in March in ACM with a federal judge of the US and 3 other computer scientists on this topic. You can find it in YouTube. So what is the question? What is the answer to this question if we need to be fair? Well, not always, as usual, but you should care about this question if you can harm people, and we'll get back to this. There are many ways to handle this. The best one will be to bias the input, but many times we don't know the bias and we don't have the right reference value. You can tune the algorithm, but then it's difficult because, again, you need to know exactly the bias you are dealing with. And finally, you can debias the output, which is the easiest, but you lost already too much information and you may not be able to mitigate the bias much. So the first time that this discrimination problem reached the headline news was for a criminal profiling support tool, Compass, that was being used in US prisons. And ProPublica showed in 2016 that there was a 2-to-1 racial bias. Well, this caused a lot of the discussion, so people didn't agree with the result. People were like outraged by this fact and so on. But then here we have 2 important questions that we need to deal with. One, is a secret algorithm ethical? Because of transparency. So if there is an algorithm that is dealing with the life of people, it should be secret. But then you need to ask the second question, is a public algorithm safe? Because then if it's public, we can game it. And this is a problem too. So there are more criminal profiling tools that are being used today. And one problem we have is that basically if police samples crime in certain regions of the city, of course you will see more crime there. So basically we have like a vicious loop where you see crime where the tool is predicting crime or the police is predicting crime. So let me give you a very detailed example of how bias can be amplified. Basically, these are bails in New York, and here in New York, it's very strange. You only need to predict if the person will come back to the court. And one problem that we don't know now is what would happen if the person had bail. So we need to do data imputation. We need to predict what would have happened of these people that didn't go out. So these researchers, which are one of the top sets of researchers in the US, and this was part of a work that they did for the National Bureau of Economic Research in the US, found that they could decrease the crime rate in 25%, keeping the same prison rate, or they could decrease the prison rate in 42%, keeping the same crime rate. So the question is, why so much difference? Well, if you see what happens, and in red you have the percentages of people of different minorities in the state of New York, so 18% are Black and 13% are Hispanic. The police already brings a bias sample. So they bring almost 50% Black and 33% Hispanic, so that shows some racism in the system. But the judges are even more racist because basically they send 57% to prison and to prison. What happened with the algorithm? Well, the algorithm learned to be racist from the data. So the algorithm was a bit more racist than the judges. So almost 60% Black and 30% Hispanic. So it learned the two trends. But if we match the algorithm to the less racist judge, we get even a 23% improvement over the crime rate. So the question is, what is happening? Well, let's assume that the algorithm is doing the right prediction. If we ask the algorithm to send more people to prison, you will see here on the left. So basically, you take the most dangerous and you keep them in prison. But if you see what a group of judges is doing, basically, if you ask the judges to do that, they are taking people from all over the distribution. So according to the algorithm, it's almost like random. So here we have a very important question. Algorithms don't have noise. So what do we prefer? A biased algorithm that is just in the sense that for the same case, you get the same sentence, or a noisy judge that depending on he slept well or he had lunch, will have a different result. Here you see the difference between exacted target, noisy target, biased target, and biased and noisy target. So bias is the case of the algorithm, bias and noisy is the case of the judge. I was using for this a paper that Daniel Kahneman and co-authors published in 2016 in the Harvard Business Review. But last May, he published a book about this, Noise, so basically a flaw in human judgment, that where he explained with two other authors why noise is so dangerous in the variance of human decisions. Well, facial recognition, one problem is that most of the results that we have today were done with images taken from the web without consent. So there was an ethical issue in how this technology developed. And because of the mistakes, especially with African American, in June last year, top companies decided not to sell this software any longer to police. We also at the ACM Technology Policy Committee, we asked this to be suspended also in June, but this was too late. The software was already being used. And for example, a second case of a wrong conviction happened on September last year. And this probably it will keep happening if we are using this software that don't work very well with Black people. Even we have problems of gender bias, and this is an example that I showed in smartcon a few years ago, but now Google fixed it. So you see that because you don't have gender in pronouns, you get the wrong translation. But now, if you do it today, you will see that both of them are female. You have also problems in information extraction, again, gender bias. You have stereotypes. For example, here you see the stereotypes of professions for different ethnic origin. You have issues in language models. So for example, language models are very large models where you can complete text, And early this year, there was a paper that showed that GPT-3 had Muslim bias. So basically, if you have the sentence, two Muslims walked into A, these are the completions of the system, you see that most of them are violent. And if you compare with other religions, you see that the violent completions are 4 times more frequent for Muslims than from Christians. So this comes from the news. And then you see that for Buddhist atheists are the less violent. But it can be much more complicated. For example, in the UK, there were, last year they tried to predict the COVID scores, and you see that they made the mistakes, and basically they had to backtrack this. A very important case in Italy, where Deliveroo had to do, was accused of implicit bias because of an algorithm that was basically discriminating riders, and in this case, the riders were just because they couldn't deliver at night. So there was a very specific case of bias coming from the optimization function. And the worst case was in Netherlands in 20,000, where 20,000 families were falsely accused of basically this being cheating in subsidies for childcare. And at the end, the whole government of Netherlands had to resign because of this scandal. Okay, second problem is what is called physiognomy, basically trying to predict the personality trait from your face. And here, for example, people that have different sexual orientation complain. Also in China and the US, they did it for criminal profiling. So based on your face, they say that they can know if you are a criminal. And finally, again, Kosinski this year, using faces to do political orientation of people. So what is this? This is what was called the phrenology, and was very famous in the 19th century, but now today we know it's a pseudoscience. And here is an example of the house of one of the people that was behind this, Dr. Cesare Lombroso in Torino, that collected many, many scores of people that he thought were criminals. But it can be worse. So in 2019, there was a paper in MIT that shows that you can get my face from your voice, which is very hard to believe in general. And then I can do my master algorithm on phrenology. Basically, I can predict your name. Yes, there is a patent for Mitchell that says that I can predict your name, and then I can know if you're an opposer, homosexual, or criminal. Third problem, stupid models. In 1979, George Box said all models are wrong, but some are useful. And then you have problems like this. Elon Musk says use Signal, and then software that use Twitter data buy stock from a company that has nothing to do with Signal, the chat software. Or for example, someone in Facebook that thought that would be a good idea to use an English-trained software in France, and then you got the town of Bitche without a Facebook page for 3 weeks because there was no human in the loop. Or for example, this example in the right from adversarial AI, where you change a pixel and then you change the label of a person or a dog or a bird and so on. So we need to understand the limitations. So we cannot learn what is not in the data. That was the case of the woman that died in Arizona because of a self-driving car from Uber. So she didn't cross in the right place, and was also at night and in the bike. So this was not on the training data. And accuracy is not the key. The key should be the impact of errors. I don't care if you have 99% accuracy if you kill people in the other 1%. And so when you are not sure, you need to be humble and say, I don't know. Very few models say, I don't know, when they're not sure. Waste of resource, the last problem. So for example, to train a language model, you can have 57 years of the carbon footprint of a normal person, or you spend between $1 and $3 million in this. So we're wasting money to basically train models that have bias, for example. Now, there was an important paper that triggered all this. This is stochastic parrot paper, and this was the paper that made Timothy Gebru be fired in Google, and also later, also Margaret Mitchell, the co-lead of the ethics team, also she was fired. So this is kind of ethics problem. It's very hard to have ethics if the company has problem dealing with ethics. So in 2017, the ACM proposed 7 properties that an algorithm should fulfill. Today, almost no algorithm fulfills any of these properties. And one reason is that systems need to be much better than people, although they are learning from us, because people is much harder on machines. And there's a new book from Cesar Hidalgo and colleagues that shows how humans judge machines, and they're much harsher with machines. So I have my own classification of the 30 properties that software should fulfill. And here divided in awareness, data provenance, completeness, usability, transparency, and responsibility. There are people already working on how to do basically trustworthy software. And the question in the future will be how we can do software using AI to do trustworthy software. And then we have problems with identity, data protection, and privacy. We skip this, but I want to go to the Article 22 of GDPR, the Data Protection Directive of the European Union. And the last line says that you can contest the decision. And that means that you need to do interpretability if you want to explain how you process data. You need to have explainability if you want to have people contesting the result. And you need to do continuous validation, testing, and maintenance if you want to keep the system working as you predict. So in last year was also a very important case of GDPR in France, where we're using video cameras in a school, and they showed that basically there was a competence problem. They couldn't decide that. There was a consent problem. People entering the school couldn't consent to use of video surveillance. And finally, the solution was not proportional, because for securing a school, you don't need a video camera. So last April, we had the proposal for AI in the EU, and it's based on risk. And here there's a first problem, because it's basically forbidden systems, high risk and low risk. So these are 4 different kinds. So there will be no risk, there are medium risk. And here, as you know, risk is a continuous variable. So this categorization will create problems with companies, because they will try to be on the lowest risk possible. Here you have Article 5, which is the one on forbidden use of, for example, subliminal techniques that may cause physical or psychological harm. So here it says basically if you offer so you have psychological or physical harm. That means that if you propose advertising of fast food to a person that has a metabolic illness, that should be forbidden. So to finish, so you have registering algorithms, you have auditing algorithms. There was a very interesting paper by the auditing algorithms group of Northeastern in March. You can check, it's a full audit to a candidate screening software. And then we have our professional biases. So we look always to small data, and maybe we are reflecting the biases of the designers and coders. Here you have two words that recently show that. And finally, we have many biases on the evaluation of these softwares. So what we can do, try to mitigate bias in data, try to make aware both the software and the user of the biases. And of course, not to fool yourself when you do the evaluation. So some recommendations, I will not read all of them. You can check it, I can send the presentation later. I prefer to say that we need to be in control and the machines in the loop, not humans in the loop. And very important, ethics is not only about you, it's also the ethics of your providers and the ethics of your clients. So basically remember that any system are a mirror of us. You need to be aware of your own biases and your own ethics to start. This is the first step. And Hazel Henderson asked this year if AI algorithms can ever be ethical. One reason ethics is something human, so algorithms itself cannot be ethical. So I prefer to use AI ethics instead of ethical AI. And finally, something obvious but very important, David Lauer says, you cannot have AI ethics without ethics, which is obvious, but someone has to say it. So thank you.
Ricardo, thank you very much. It was certainly a very interesting and intriguing presentation, but it also has quite scary implications at the same time. So my main takeaway is that the developers of these systems should be ethical in the first place in order to develop AI ethics or ethical.
Also, they should be diverse. They should include women, minorities, and different geographies, different cultures, different languages. A lot of bias is encoded in the language.
Wonderful. Thank you very much for your great presentation.